All right, so in the next 3 to 4 slides, we will be talking about specifically how do our bones remodel themselves if we have an increased demand or we have a bone break. So first and foremost, one of the things we need to talk about is the fact that our bones are not stationary. Obviously, we know we bones when we undergo a growth spurt, but even when we are 35, 45, etc. years old, we are still going to be creating bone and adjusting our bones to meet our lifestyle demands. For instance, your brain doesn't technically stop growing until the age of 25, roughly. So even though I will be done my growth spurt probably by 16, 18 years old, my skull is going to continue to grow to accommodate my enlarged brain until about the age of 25. When I first learned to walk, up until when I'm a baby. Up until that point, my bones haven't really needed to support my weight, so they haven't really need to be dense and strong. Well, once I start to learn how to walk, they need to adjust themselves, strengthen themselves, lengthen themselves, do what they need to do to meet the stresses placed upon them by me walking and then eventually running and jumping. Individuals who have a history of manual labor, so people who work the fields, work construction, etc., they traditionally have a greater bone mass and density. Athletes, same thing. Why? Because of muscles. So one of the things we're going to talk about in the muscle section is when a muscle contracts, it is attached to a bone by a tendon. When a muscle contracts, the tendon pulls on the bone. And by pulling on the bone, it moves the bone. So if I'm trying to do a bicep curl, and you can't see me right now, I am doing a bicep curl. And I encourage you guys to do one with me and walk yourself through this. Visualize yourself through this. I contract my bicep to do a bicep curl. The tendon pulls on the bones of my forearm, moving my forearm, closing the elbow angle, moving my hand towards my shoulder. And that's because that tendon is pulling on the bone. So, what does that have to do? Why do people who have more muscles have greater bone density and mass? It's because the more forceful the contraction, so the stronger the contraction, the greater the pull on the bone. If I do not want my tendon to just rip right off the bone, and therefore not move my forearm, my bones have to increase their density and mass to be able to withstand that contraction force. So the stronger the contractions of my muscles, the stronger my bones need to be to meet that force. Why does this matter? Well, there's this annoying condition called osteoporosis that we will be talking about actually in the next audio. Osteoporosis is a loss of bone mass, traditionally associated with women. What else do women traditionally have less of? Muscle mass. So one of the things, depending on your age, for those of you who are listening to this, if you've been around long enough, you will have seen how we address osteoporosis change over the past 3 to 4 decades. Starting in about the early 90s, we were telling women to take your calcium supplements, and then it got adjusted to make sure it's a calcium with a vitamin D, and then it got adjusted into phosphorus and magnesium calcium supplement. Towards the late 90s, we started advising women to do weight-bearing exercises to strengthen their bones and promote bone mass and keep the bone mass they have. Do not get me wrong. Weight-bearing exercises are fantastic. And if you have joint issues, getting in the pool, chef's kiss. Swimming is one of the best exercises if you have mobility issues because the water supports you but it also kind of acts as a resistance. So when I go to walk through the water, I have to use a little bit more muscle. I have to use a little bit more effort. So getting in the water, one of the best things for people if they have mobility issues. Anyway, so we started telling them weight bearing exercise. Swimming, walking, running was not advised, but specifically walking and swimming. Fantastic. Use the muscle, make contractions, pull on the bones. Good stuff. However, as we started to shift into the early 2000s, end of the beginning of 2010s, we started shifting that towards lifting light weights. And then the current advice, if you're following the actual research guidelines, not what is currently in practice, there is a difference between that. Current medical guidelines are usually about 10 to 20 years behind research guidelines, and that's due to a variety of different things. And this is pretty globally, usually about 10 years behind. But the current research guidelines are lift as heavy as you can. Lift as heavy as you can, and then try and lift heavier. And you are starting to see that in practices as well. Why? Because what the researchers did is they looked at men. Men also get osteoporosis, but they get it at a far less significant rate. Yes, they don't have the drop due to the estrogen, all of that fun stuff, but what's the other thing they typically have? Traditionally, male individuals have more muscle mass. They tend to be involved in more sports. They tend to go and actually lift heavy weights more frequently. They tend to be in more manually intensive jobs. More muscle mass, pulling on their bones creates stronger bones. So when they do have that hormone drop, because they do have a hormone drop, their bones they start at 100 and have to get down to 0, versus women's traditionally are starting more at like 50 and getting to 0. So we start closer to the problem zone, so to speak. So, lift. That's all I have to say about that. It's skeletal muscle. We keep doing more research on it, even though it's one of the things that we're like, oh yeah, we know all there is to know about it. And we kind of do. But more and more studies have shown, longevity studies have shown, chronic illness studies have shown that the more skeletal muscle mass a person has going into old age, the better their overall health outcomes are. So just food for thought, be male or female or NB, muscle mass. It's for everybody. Anyway, back to what I'm actually supposed to be talking about. So, bones, constantly growing, constantly remodeling, constantly adjusting themselves. During a unique phase of our lives, up until whenever our growth spurt ends, we will have cartilage that is also growing along with the bone. As we mentioned in the previous audio, that is how we get our bones growing lengthwise. Width, however, this is what is constantly being adjusted throughout our life. Length will be set in stone. Width is what is constantly adjusting itself. And width is what we are concerned about when it comes to bone density and bone mass for conditions like osteoporosis. So how do we get more width? Well, our osteoblasts are going to lay down more matrix, so more collagen fibers that become embedded with the calcium, and they form that bony matrix, hardening and solidifying, and create more bone in layers to parallel to the outer surface, and the osteoclasts dissolve bone on the inner surface. The osteoblasts build out, osteoclasts kind of shape everything on the inside. If one process outpaces the other, that is when we get bone deformities such as osteitis deformans. So if I have too much osteoclastic activity, I'm going to eat through my bone, and have holes and dips and divots that I shouldn't have. If my osteoblasts outpace my osteoclasts, then I'm going to have bony protrusions and growths that I shouldn't have. And here is reiteration of that. Cartilage grows, cartilage replaced, cartilage grows, cartilage replaced. Constantly. So cartilage grows, replaced. Grows, replaced. During our growth spurts, this is very evident at the epiphyseal plate, otherwise known as the growth plate. Right. Osteoblasts, beneath that periosteum, beneath that bone membrane, are going to secrete that bony matrix straight onto the external surface. This slide is essentially just reiterating in a different format the things that came before. So osteoblasts secrete, making it thicker. Osteoclasts on the inner membrane break down bone, widening the medullary cavity. Why is that important? Medullary cavity is where we're going to have our bone marrow, both red and yellow. So, strong, healthy bones can also mean strong, healthy red blood cells and circulatory system. Everything kind of feeds into itself here. All right, that is the end of that audio. Actually, it's a really short one except for my soapbox. The next audio, we're actually going to talk about a couple of bone conditions: rickets, osteomalacia, osteoporosis, again, and other homeostatic imbalances.